In our second tutorial, we will use synthetic division and quadratic formula to find all roots for a polynomial function. So let's flip over to our next section, and we're going to be looking for all zeros. And here's our quick four-step process. First of all, we're going to be looking at the degree. The degree will tell us how many total solutions we're looking for, how many zeros. And then number two, for efficiency, we're going to use our calculator to find any of the real rational zeros. And what I mean by that is we've already looked at this before, but we're going to push apps, the apps button. We're going to go to number 4, which is the polynomial, and then I think there's a 2 there, app. And then we're going to do number 1, the root finder. So we're going to let the calculator do a lot of the work for us to find our real rational roots, and it'll help us find some imaginary. Once we have those, we're going to use synthetic division to depress our polynomial until it's down to a quadratic. Because once we have a quadratic, we can use quadratic formula to find any irrational or imaginary zeros. Okay, so let's go through that process with our first one, a of x. It's a cubic, so I'm going to plug this into the calc. First of all, I know that there's going to be 3 solutions because it's a cubic. So let's open up our calculators. If you don't have a calculator, go grab one, pause the video, and go get your calculator so that you can follow along. We need to push the apps button. Number 4 is the polynomial. I think I forgot a T in my notes, so I'll do that. Here's a 4. And it says press any key, so I'll just push enter. We're going to look at number 1, the polynomial root finder. So we can push 1 or we can just push enter. Now by default it thinks that it's going to be a quadratic, so we do need to move this over to a cubic in this case and push enter. We also do not want it to be on real because we might have imaginary solutions too. So let's put it in complex mode, a plus bi. And we'll keep everything else the same. We'll have our answers as fractions. So then I'm going to click next, which is the graph button up here. Now here's our standard form for what we have, and we're looking for our coefficients in order. So the first one is 1, then negative 11, then 40, then negative 50. So let's input those, 1, and then negative 11, and I'll just push enter, and then 40, and then negative 50, enter. Once you have all 4 coefficients in order, let's hit solve. Boop. And there it is. It solved it for us. One of the answers is 5, and the other 2 answers are 3 plus I and 3 minus I. That's great. The calculator's basically done all of the work for us. Let's go ahead and write that down. X equals 5 and 3. I'm going to write it as 3 plus or minus I. Now here's the deal. I need for you to prove that this is correct. Obviously only one of these answers is real. We're going to prove that this answer is real by using synthetic division. I'm going to put the 5 that the calculator has already said is a solution, and I'm going to put it into our synthetic division. So my coefficients again were 1, negative 11, 40, and negative 50. And let's do our synthetic division. So we drop down that 1. 5 times 1 is 5. Add this up and we get negative 6. 5 times negative 6 is negative 30. Add this up and we get 10. 5 times 10 is 50, and we've just proven, because we do get our 0, we've proven that 5 is one of our answers. I'll put a little check mark. We've shown the work to prove that. The other 2 answers are imaginary. So yes, this is a quadratic that's left, x squared minus 6x plus 10, but it will not factor like before because we do not have rational solutions. We have imaginary. The only way to find those are quadratic formula or completing the square. I'm going to choose quadratic formula, so this must mean that this is A, and this is B, and this is C for our quadratic formula. I like to start with my discriminant. I'm going to come over here and do the discriminant. So b squared minus 4ac. So since b is negative 6, I've got negative 6 squared minus 4 times a is 1, and c is 10. 36 is what negative 6 squared is. And this is 4 times 1 times 10, which is 40, so negative 40. 36 minus 40 is negative 4. That's why we have imaginary solutions, because the discriminant is negative. Okay, great. So now let's plug into our quadratic formula. Let's remind ourselves what the quadratic formula is. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. Let's substitute into all of the places here. The opposite of b was negative 6, so the opposite of negative 6 is positive 6. Plus or minus the square root of, I already found all of that, and that was negative 4, so I'll put that there. And then 2 times a is not too difficult. That's just 2 times 1, which is just 2. Great, so we substituted into our quadratic formula. Now let's simplify the square root of negative 4. That's a perfect square. The first thing we'll do is pull out the square root of negative 1 as an I, but the square root of 4 is 2, so the square root of negative 4 is 2i. Divide that by 2. I see that all three of these parts are even, so I can cut them all in half. I've got 3 plus or minus 1i. Hey, those are my two answers. So now I've checked that those are correct, and now I can box in my answer. I know that the calculator gave us these answers, but I need for the work to prove that the calculator is correct. And that's our process. Use your calculator to find any of the real rational solutions. Divide those with your synthetic division to get down to a quadratic, and then use quadratic formula to prove the other two answers, or to find the other two answers. That's it. Let's try it again. Here's our new cubic. Let's use our calculator first to see what happens. Now, I can just hit I've already done this once, so I can hit coefficients and just go change my coefficients because we still have a cubic. So that's fine. I'm going to keep that first one as a 1, and the next coefficient is supposed to be negative 6, and then a negative 7, and then an 18. So those are my 4 coefficients. I'll double check those. They're correct, and I'll hit solve. All right. Ew. Okay, so this one, really there's only one nice number, the negative 2. The other ones must be irrational. And I don't want the decimals, I want the exact answers. So the calculator was really only good for 1/3 of our answers. But that's good. I've got my negative 2. That's better than having to do my P over Q and test to see which ones work. I know that x equals negative 2. Great. So let's plug the negative 2 into the box and do our synthetic division. My coefficients again were 1, negative 6, negative 7, and 18. Let's drop the 1 down and let's multiply and then add. And then multiply and then add. And then multiply, and because we know that that was a 0, we should be getting the 0 as the remainder. And I know that this will not factor because the other answers from the calculator were not nice answers. So this must be A, B, and C, and I will use quadratic formula. Again, I'm going to do my discriminant, b squared minus 4ac. This is negative 8 squared minus 4 times 1 times 9. This is 64 minus 4 times 1 times 9 is 36, so 64 minus 36. 64 minus 36 is 28. 28 is my discriminant. I know that since this is a positive number, that my answers are still real, but because it's not a perfect square, they are going to be irrational. So I'm going to come in and plug into my quadratic formula. So x equals the opposite of b. The opposite of b would be positive 8, plus or minus the square root of that 28 that we just found, all divided by 2 times a, which is 2 times 1, which is just 2. Okay, great. And now we just have to simplify our radical. I'll come off to the side and do that. The square root of 28 is no good, but I know that 28 is 4 times 7. 4 is a perfect square, so that's nice. The square root of 4 turns into 2, and we still have that square root of 7. And I'll bring it on back in, and now I've got 8 plus or minus 2 square root of 7 divided by 2. If this is too fast for the quadratic formula, go back and rewatch the quadratic formula tutorial for some more hints and tricks on how to do that. So now we're looking pretty good. Oh, I'm looking at all three of these spots, and again, I see that all three of these spots are even, so I can cut them all in half. So 8 cut in half is 4, 2 cut in half is 1. I don't need to write it because I have that square root of 7 there. All divided by 2 cut in half again is 1. So I don't really need that. I have my other two answers. Let's put them up here with our original answer, and we'll say 4 plus or minus the square root of 7. And we have all three answers to our cubic. So again, the calculator is helpful, but it will not show you the irrational solutions. So you need quadratic formula to be able to find those, but you can't use quadratic formula until you depress the cubic into a quadratic by doing synthetic division. All right, last example. This one is a quartic. I'm looking at the degree. I know that there will be 4 answers. Let's have the calculator see how many they can find. And we can't do that. We've got to go back to the main and hit polynomial root finder and change it to quartic. So that's number 4, or degree 4. We still want to be in imaginary form, so that's fine, imaginary mode. And I'll hit next. And let's see what we've got. I've got 8, and then 32, and then 1, and then 4. But I'm supposed to have 5 coefficients. So something must be missing here, and I see it. It's missing right here. There's a 0x squared that's missing, the quadratic term right there. So don't forget that. Don't forget the 0. So I've got my 8, and then my 32, and then my 0, and then the next coefficient is 1, and then 4. Okay, that's better. I have them all. We'll hit solve, and let's see what we've got. Uh-oh. Well, I see a nice number, -4. I see a relatively nice number, -0.5. And then I see some imaginaries because I see the I, but even just kind of gross imaginaries. But at least half of my answers I know, -4 and -1/2. So let's write those down. -4 and -1/2. There are 2 other answers that I'll put, but I'll leave that for a bit. So we've got to depress. I'll use my -4 first. Use these coefficients. I've got 8 and 32 and 0 and 1 and 4. And let's go. Drop down the 8, and I've got -32 when I multiply. That gives me 0. Multiply, I get 0. Add, I get 0. Multiply, I get 0. Add, I get 1. -4 times 1 is -4, and lo and behold, I get my 0. But this was a quartic, so it's only been depressed once. Now it's cubic. So it's still not quadratic, so you know what I need to do? I need to divide again. I call this a nice double stack. I've already used the -4 and I've proven that it's a 0. Now let's use -1/2. We can do that. That's not a problem. Drop down the 8 yet again. -1/2 times 8 is -4. Add it up. -1/2 times -4 is +2. Add it up. -1/2 times +2 is -1. Add it up, and we've proven that that is also a 0. And we've taken an 8x to the 4th, depressed it to 8x cubed, and now depressed it to 8x squared. So this is my quadratic. And since the other answers I need quadratic formula, I'm going to write a, b, and c, and let's do our quadratic formula. b squared minus 4ac. So what do we have here? -4 squared minus 4 times 8 times 2. So this is 16 minus 4 times 8 times 2 is 64. And that gives me a -48 for my discriminant. So I must have had imaginary solutions. Well, let's bring it on over here and plug into quadratic formula. The opposite of b this time is +4. Plus or minus the square root of that -48 that we just calculated, and 2 times a would be 16. All right. We like to go simplify our square root next, so I'll do this. I'll pull that square root of -1 out as I times the square root of +48. 48's no good, but I know that 16 goes in there 3 times, so that's nice. So this is 4i times the square root of +3. Bring that on back in. I'm getting there. Here I am. 4i square root of 3 all over 16. All of these are even, but even better, they're all divisible by 4. So I can divide everything by 4, and I will have my final answers. 4 divided by 4 is 1. 4i divided by 4 would just be 1i, so I'll just write it as I. Don't forget that the square root of 3, of course, is just attached there. 16 divided by 4 is 4. Ugly looking answers, but there they are. And let's put them over here with the other ones. 1 plus or minus I square root of 3 all over 4. And there we go. Thanks for watching this tutorial, and I'll see you in class so we can practice this some more. See ya.